To execute a number ticker, there are two phases. The first is to render all of the items that you want hidden, and then the second is to measure one of those items and then determine the offsets for each of the characters that we need to scroll to. So first, let's render our number range. We have a number range from 0 to 9, and we'll just loop over that. We can either use the value provided or the integer, it doesn't really matter, the index. So now we save this, and we can see that we now have a list of items that are rendering in a column. We'll then supply a key just so we can quiet our error messages. And so that the text is big enough to deal with, we're going to create a text class, give it a font size of 80 and a color of gray, and apply that to each of them. Now, in order for these to be hidden, we need to wrap this in another view and then apply overflow hidden. On iOS, overflow hidden is an option. However, on Android, overflow hidden is the default and the only option for a view. So let's apply a wrapping view. We'll simply just give it a hidden class, say overflow hidden, and then apply that to our wrapping class. Now nothing has changed because the text is actually affecting the layout of this view. So each one of these rendered in a column on top of each other is adding to the overall size of this particular view. So we need to measure one single character and then apply that height to this view, and that way our overflow hidden will actually take effect. If we supply a random height, let's just say it's a height of 95, we can see that it is restricting to a single character being shown. So let's remove that, and now we'll measure the layout of a single one of these characters. To measure, we'll need to apply another text element. We'll give it our style equals styles.text, and then we'll put a random character in here that's included in our numbers range, so we'll just say 0. And then we'll also need to apply an opacity of 0 to this text element. And the reason is we want the layout to be displayed, but we don't want this to actually cause any effect on this particular layout. So let's just give it a measure class. We'll say opacity of 0, and we'll apply styles.measure. Now we need to set up something to receive the layout for this text element. So we'll create a handle layout function that receives an event, and then we'll do a this.setState of measured of true, so we know that we've measured something, and then we'll set the height of e.nativeEvent.layout.height. Additionally, we'll set up some default state. So state equals measured false and height of 0. So now we can apply our onLayout equals this.handle layout to our text element. And then additionally, we'll supply another style here and say height is equal to this.state.height. And now that we've done that, what's happened is we do a measurement, we eventually set our state here to the height, and then this will go from a 0 height with an overflow hidden to a height of whatever this particular character is. We don't necessarily want this particular view to be hidden until stuff is measured, so let's clean up our styling a little bit. We'll remove this, and we'll just say const height and measured equals this.state. Then we'll create another variable called const wrap style. And if we've measured something, then we'll return height as our style. Otherwise, we'll return styles.measure, which styles.measure is just overflow or opacity 0. So now we can apply our wrap style here, save, and nothing has changed. So now that we have this working, we need to fix this so that when we have a specified value, we can figure out at what position it is. So 1 would be here, 2 would be here. So now that we have access to the height, we can create a function that determines the translate for the transform that we need. And the reason we're using translate transform is because it's going to be performant and allow us to use the native driver when we're doing our animations. So let's create a function called const get position. It'll receive the value and the height. And then we'll just do a parse int on our value just to be sure. We'll multiply it by the height, and then we'll also multiply it by -1, because translate y, if it's positive, will move the view downwards, or if it's negative, it'll move it up. So because our starting value is at this position, we need to move the value upwards to get to the other characters. And then finally, we'll create a translate style. So we're going to say const get translate style. We'll get our position. And we'll just return transform with an array and a single translate y with our position. Now we need to apply this style, but because this is the overflow hidden container and there's nothing else inside of here, we need to wrap this in another view that will basically act as a scroll within this particular hidden container. So apply our view, and then we'll get our transform style, which is going to be equal to the get position of the value that we want. So for example, let's say we want 5, and then we'll pass in the height, and then we'll wrap that in our get translate style. And now we can apply our transform style to the view. So we'll say style equals transform style. Once we save, we can see that it is figured out based upon the height and the value that we've given it, which value to select within the range. Now to show that this is working, let's remove the styles.hidden. We can save it and see that in the center of the screen, the 5 is exactly where we wanted it to be. If we change this to say 9, it'll scroll all the way to the end, or 0, go all the way to the other side. So let's add our styles.hidden back. And we can add a value to our state, just start at 0. And our component did mount, we'll set an interval and do a this.setState to a value of this.state.value plus 1. And we'll do that every 1,000 milliseconds. And then we'll pipe our this.state.value into our transform style, just as an example. And now we can see that it's actually ticking from 0 all the way up based upon the value that we are setting.